the probability of an event. We write it generally P, a capital P, of the event. So this is another common function that we're going to be using in this class. We're not going to be talking about profit anymore in this class, so there shouldn't hopefully be any confusion between profit function versus probability of something. We're not dealing with profit functions anymore, so you can just kind of, well, forget that, I suppose. Probably not good to actually completely forget it, just know that we're not talking about it in this class. We are using n of e and n of s. E is our event, so we're talking about the number of outcomes in our event, and n of s is our sample space, so n of s would be the number of outcomes in our sample space. So the probability of an event is taking the number of outcomes in our event divided by the number of outcomes in our sample space. This does assume that all the outcomes in our sample space are equally likely. So this is kind of why it's important that you make sure that all the outcomes are equally likely in order to use this n of e over n of s, and we will use that quite a bit. So for instance, if you roll a 6-sided die, the probability of getting a 3 or greater, we just saw that e was the event, e was the outcomes where we had 3, 4, 5, or 6. There are 4 different outcomes there. N of s is 6 because, well, our sample space was 1 through 6. So the probability of getting a 3 or greater is going to be 4, that's the number of outcomes in this event, divided by 6, the number of outcomes in our sample space. And of course we could reduce that down to 2/3. In general, when we're talking about the probability of an event, the probability will always actually not just the probability of an event, probabilities just in general, will always be between 0 and 1. They might be exactly equal to 0. We can talk about the probability of something that can't ever happen. We would say that that has a probability of 0. Or we could say the probability of something that is guaranteed to happen. We would say that has a probability of 1, a certain event versus an impossible event, or whatever you want to call it. In general, most of the probabilities we talk about are going to be between 0 and 1, and you can actually kind of see why it has to be between 0 and 1. If we're counting something up, the number of outcomes in the event has to be, well, bigger than 0. It has to be 0 or bigger, I suppose. So you can't have a negative number up there. And your event is a subset of your sample space. So it is no bigger than your sample space. The number of outcomes in your event is no bigger than the number of outcomes in your sample space. So that's why we know it can't get over 1.